guys, welcome back to the Intellectuals. Today we're going to be looking at calculations which are for all students. Now first we're going to be looking at relative formula mass. Now atoms have very little mass, so instead of using their actual masses in kilograms, their relative atomic mass is used. The relative atomic mass of an element, symbol AR, is defined as the relative mass of its atoms compared to the mass of a particular carbon atom. Calculating relative formula mass. The relative formula mass of a substance made up of molecules is the sum of the relative atomic masses of the atoms in the numbers shown in the formula. Relative formula mass has the symbol Mr. To calculate Mr for a substance, you have to work out how many atoms of each element are in the chemical formula, and then you have to add together the Ar values for all the atoms of each element. Relative formula masses of ionic compounds. Ionic compounds such as sodium chloride don't exist as molecules. However, their relative formula masses are calculated in the same way. Empirical formula. The empirical formula of a substance is the simplest whole number ratio of the atoms of each element present. Converting empirical formula to molecular formula. The molecular formula for a substance can be worked out using the empirical formula and the relative formula mass. Law of conservation of mass. No atoms are created or destroyed in a chemical reaction. Instead, they just join together in a different way than they were before the reaction and form products. This means that the total mass of the products in a chemical reaction will be the same as the total mass of the reactants. The total mass stays the same during the chemical reaction. This is the law of conservation of mass. Concentration of solution. A solution forms when a solute dissolves in a solvent. The concentration of a solution is a measure of how crowded the solute particles are. The more concentrated the solution, the more particles it contains in a given volume. Calculating concentration. The concentration of a solution can be calculated using the mass of dissolved solute in grams and the volume of solution or solvent in cubic decimeters. Calculations for higher tier only. The mole. The actual masses of atoms and molecules are too small to be of practical use in calculations. Therefore, a special quantity called a mole is used. In terms of mass, a mole is the relative atomic mass of an element in grams, or the relative formula mass in grams if it's a compound. Avogadro constant. As the mole quantity is based on the relative masses of atoms, there is a relationship between a mole of a substance and the number of particles it contains. As atoms and molecules are so small, the number in a mole is very large. Calculating the number of particles. The number of particles of a substance can be calculated using the Avogadro constant number, the amount of substance in mole, and the number of particles, which equals to 6.02 times by 1023 times by the moles. Moles and masses. The mass of a substance can be calculated from the number of moles, and the number of moles of a substance can be calculated from its mass. The link between the two quantities is the Mr relative formula mass. Calculating moles. The amount of a given mass substance is calculated using this formula. Amount in moles equals mass in grams divided by the Mr. Reactions and moles. Limiting reactants. A reaction finishes when one of the reactants is all used up. The other reactant has nothing left to react with, so some of it is left over. The reactant that is all used up is called the limiting reactant. The reactant that is left over is described as being in excess. The mass of product formed in a reaction depends upon the mass of the limiting reactant. This is because no more product can form when the limiting reactant is all used up. Reacting mass calculations. The maximum mass of product formed in a reaction can be calculated using the balanced equation, the mass of the limiting reactant, and the relative atomic mass or relative formula mass values of the limiting reactant and the product. You can click the link in the description to view this presentation. Thanks for watching. Bye!